Hey everyone, this is section 2.5, Reasoning in Geometry. Okay, they do now ask you to match the property to its correct example. What you need to do is just browse through the examples and look for the given property. So addition property, I'm going to look through my examples here, and I see addition down at number 6. A plus C is equal to B plus C. That just means if you add C to the left side of your equation, you have to add it to the right side too. That is your addition property, example 6. Subtraction property, same theory, but if you subtract from one side, you need to subtract on the other side with the same value. That is example number 5. Your multiplication property is if you multiply on one side of your equation, you have to multiply on the other side by the same value. That is example 3. Your division property of equality is if you divide on one side of your equal sign, you need to divide on the other side by the same value. That's example number 1. Whoops. Your reflexive property, your symmetric property, and your transitive property. These are 3 new terms that we're going to learn about today. Okay? Your reflexive property means the left side of your equal sign is equal to the right side of your equal sign. And that's usually or always with the reflexive property the same term. A equals A. That's your reflexive property. Your symmetric property is almost like a mirror image from one side of your equal sign to the other, okay? So symmetric property would be if A is equal to B, then B is equal to A, okay? That is your symmetric property. Example 2. Transitive property, we kind of talked about this with our statements in the last section. You know, we said if the students don't study, then the students will fail their quiz. If the students fail their quiz, then Mr. P will be disappointed. So if the students don't study, ultimately Mr. P is going to be disappointed. That's the transitive property. Okay, so your transitive property is if A equals B and B equals C, then A must also equal C. So that's your transitive property. Substitution, that's replacement, right? If A equals B, then B can replace A in any given expression. Example 4. All right, you have several vocabulary terms that we need to learn: the reflexive, the symmetric, and the transitive. Remember, we just talked about reflexive is when the left side and the right side of your equal sign are identical. AB is equal to AB, angle A is equal to angle A, right? That's your reflexive property. Symmetric property we just talked about is kind of like that mirror image. If AB is equal to CD, then CD is equal to AB, okay? You just flip your equation over. Transitive property, well, that's that one that we just talked about and discussed on the last page. If AB is equal to CD and CD is equal to EF, then AB is equal to EF. Okay, the transitive property could also look like angles, right? So if angle A is equal to angle B and angle B is equal to angle C, then angle A is equal to angle C. All right, so those are our 3 new properties that we're learning today. So justifications. This is a huge portion of geometry. There's always questions on your Regents exam about justifying, and you know, this is going to be our first go around with this. It's going to be difficult. It's different. We're used to solving algebraically, solving using geometry geometrically, but we're not used to explaining why or providing a reason for each step that we're doing. You know, in geometry, whenever we get a question like this, we're going to have to justify. Okay, so they're asking us what is the value of x and justify each step. So they give us our graphic here. We have a straight line created by 2 separate angles. So these are called linear pairs because they make 180 degrees, right? Or supplementary is a good term that we also use. So that's where we're going to start. Angle AOM and angle MOC are supplementary angles, okay? And AOM and MOC are a linear pair. That's going to be our justification. They create a straight line, therefore they must be supplementary. Now that we've proved or written this and justified it, we can now write our equation. Angle AOM plus angle MOC is equal to 180 degrees. And that's the definition of supplementary angles. All supplementary angles equal 180. Now, angle AOM I'm going to replace with its expression, 2x plus 30. So we plugged in for AOM, 2x plus 30. And for MOC, we plugged in x. And they're still equal to 180. So when we plug in or replace, that's called the substitution property. Okay, from here we combine 2x plus x, which made 3x. And when we combine terms that have the same variable, that's called combining like terms. Okay, from here it's a normal two-step equation. We would have to subtract 30 on both sides. And when you subtract 30 from the left side of your equation and the right side of your equation, that's your subtraction property. Last, they divided by 3 on both sides, and x equaled 50. Well, when you divide on both sides your equal sign, that's the division property. Okay, I know it's a lot to write. I know these can be tedious. This is the first of many that we will do. And, this is just standard, part 2, part 3, part 4 on your geometry regions. So, here's a new example, okay? What does the value of x justify each step? So we have angle RAN, and it's split up into two angles, RAB and BAN. Okay, one is x, one is 2x minus 75. Now, this time they gave us a given. They said ray AB, meaning this line, bisects angle RAN, which means that RAB and BAN must be equal to each other. That's the definition of an angle bisector. So now that we have our equation, we can substitute in for RAB, x, and that's going to equal angle BAN, which is 2x minus 75. And when we substitute in, like we said, that's just our substitution property. Now we just have to solve for x, but I have an x on the left side and a 2x on the right side. Generally, I would say to move the smaller one, but if we moved x over, there would be nothing remaining on the left side of our equal sign. So this is one of those times where we're going to have to subtract the larger value over. So I'm going to subtract 2x from both sides, and we're going to result with negative 1x is equal to negative 75. And when we subtract on the left side and the right side of our equal sign, that's the subtraction property. Last, we have a negative 1 being multiplied by x. I need to divide by negative 1 on both sides. And that gives us x equals 75. And when you divide on the left and the right side of your equal sign, that's your division property. Okay. For number 3, they want you to write the name of the property underneath the example. So we go from 2x plus 9 equals 19 to x equals 10. And to me, that looks like they subtracted 9 on both sides. Right? And this should be 2x equals 10. That's a typo on my part. Okay, so when you subtract on both sides, that's your subtraction property of equality. All right, your next one, if angle O is equal to angle W and angle W is equal to angle L, then angle O must be equal to angle L. Well, those are kind of like our statements that we talked about before and that we've done in the last section of this course. That's your transitive property of equality. If Mr. P lets the dog, if the dog barks at the door, then Mr. P lets the dog out. If the dog goes out, then he will chase the squirrels. So ultimately, if the dog barks at the door, he will chase the squirrels. Angle E is equal to angle T, and angle T is equal to angle E. Well, that's that mirroring image of each other. And if we go back to our definitions, those mirroring images are your symmetric property. Okay, so that's the symmetric property of equality. All right, we've already completed 2 proofs with our justifications, but now we're just going to get a more formal definition of what they are. Proofs are a convincing argument that uses deductive reasoning. A two-column proof, which you can see here, a column with statements, a column with reasons, is a proof listing each step on the left, so your steps are your statements, and each reason on the right. Okay, if you notice, the first statement is usually the given statement, which we've already experienced in our second example. Each statement should follow logically from from the previous statement, so 2 would follow 1, 3 would follow 2, 4 would follow 3, and so on. And the very last statement is what we are trying to prove, okay? In this example, we're trying to prove the measure of angle AEC equals DEB. So that should be your last statement. Okay, writing a two-column proof. Given the measure of angle 1, right here, is equal to the measure of angle 3. So they want to prove that this angle, or actually they're giving us that these two angles are congruent. What we're trying to prove is that AEC is equal to DEB. So they're trying to prove, or we will be trying to prove, that this red angle here is the same exact value or equal to this angle here, our blue one. Okay, so that's what we will be trying to prove. So we know that the measure of angle 1 is equal to the measure of angle 3 because that was our given. We need to prove that AEC is equal to DEB. So our plan is going to be that we need to add angle 2 because it's shared by both the red and the blue angle in the middle to angle 1 and to angle 3. The resulting angles will have equal measure. So this is our first two-column proof. We wrote the given. The measure of angle 1 is equal to the measure of angle 3. Our second step is that the measure of angle 2 is equal to itself, right? Because we're about to use this angle in our proof. Well, when it's something equals itself, that's one of the properties we learned today that's reflexive. Angle 3, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. Okay, so 1 and 2 is equal to 3 and 2. And we're allowed to say that because it's the addition property of equality. We've already proved, or we're given, that 1 is equal to 3. So if I add angle 2 to the left side of my equation, I need to add it to the right side. That's our addition property of equality. Next is that the measure of angle 1 plus the measure of angle 2 is equal to AEC. Well, AEC, like we talked about, is right here, this angle. The measure of angle 3 plus the measure of angle 2 is equal to angle DEB, which we've also talked about on the last page. Okay. This is called the angle addition postulate. All we did was add two angles together to create a larger angle. Our last step is that the measure of angle AEC is equal to the measure of angle DEB, and that's the substitution property. Okay, we substituted 1 and 2 for AEC and 3 and 2 for DEB. Okay, again, statements and reasons, your two-column proofs. It's going to be a very different way of thinking in terms of math, and I know we've been saying that a lot this year, and it's true because geometry, takes things a step further than anything we've learned before, and, proving and writing and solving is all going to be a little unique to this course. Your exit slip. Fill in the reasons for this algebraic proof. We were given that 5x plus 1 equals 21. We're trying to prove that x equals 4. So 5x plus 1 equals 21 is going to be our what? Our given. From the given, we subtracted 1 on both sides. And when you subtract on both sides, 5x is going to equal 20. That's your subtraction property. Then x equals 4, and we got to that because we divided both sides by 5. So that's your division property. Okay. Thanks for watching. Don't forget to submit your work and definitely check in for a 10.